So in the very last question, part E, we're asked, when is the ball 11.1 meters above the ground? So it's important to take a look at our picture again and figure out what we've already found out. We already know that the maximum height of the ball is 43.2 meters. So that means that when the ball is 11 meters above the ground, it's at about that height. Now the ball is going to reach that height in two different places. That means when we solve our equation, we're going to get two different times. And both of those times are valid because we just want to know when is the ball at that height. And this height again is 11.1 meters. Now, the direction that we're most interested in this case is the y direction. So we're going to start by summarizing the information that we have in that direction. V1y, just like last time, is 29.1246 meters per second. The acceleration in the y direction is 9.81 meters per second squared down. We know the displacement that we're interested in is 11.1 meters above the ground, so it's positive 11.1 meters, and we want to know when is that going to happen. Putting those variables together, the equation that we're going to want to use is this one yet again. Substituting in some numbers, we realize pretty soon we're looking at another quadratic equation. So we're going to rearrange to make this look more like a quadratic equation. Oops, I forgot a delta t there. So here we go. Now we're going to apply the quadratic formula. Negative b plus or minus b squared take away 4ac all over 2a. Now substituting in our values, and remember, yes, I'm keeping track of significant figures still. So in this case, there's three significant figures, here's three significant figures, and there's another three significant figures. The next step, I'll just do a little bit of simplifying. 29.1246, if I plug that into my calculator, I'll get 848.2423 to three significant figures. Now I'm multiplying three negative numbers, so I'm going to end up with a negative number, and that number is going to be 217.782 with three significant figures. And in my denominator, I've got 9.81 again. So when I subtract those two numbers under the square root sign, I end up with 630.4603 with three significant figures again. So in the end, I've got negative 29.1246 with three significant figures, plus or minus 25.10897 with three significant figures, divided by negative 9.81. In this case, I definitely expect to get two different times that are perfectly valid, which means they better be positive. And the first time I get is 5.5284 seconds, rounded to three significant figures. The second time I get is 0.40934 seconds, rounded to three significant figures. And if I compare that back to my diagram at the front, that makes sense. Shortly after launch, it hits 11.1 meters for the first time, and then when it almost hits the ground, it reaches 11.1 meters above the ground again. This better be pretty close to my total time spent in the air, 5.52 seconds, and in the last question, I found out that the total time spent in the air is pretty close to that as well, so that looks about right.